is parametric relations and inverses. You've talked about inverses, okay, that will be a little familiar to you, but parametric relations is a brand new topic, okay? That's not one that you have looked at before. And so, we're going to talk about that a little bit. Before we get there, we're going to talk about what it means for a relation to be defined implicitly. So, to be honest, we prefer relations defined explicitly, okay? An implicit relation is where the relation, possibly a function, is not specifically solved for in terms of y. Okay, so in other words, something like this equation here in example 1. That is an implicit equation because, is it y equals? No. Okay, so it's implicit. We prefer explicit though because it's so much easier to work with when it's y equals, isn't it? I can plug numbers in pretty easily. I can plug it into the calculator to graph it pretty easily. So now, as we talk about that implicit, basic question here, determine which of the ordered pairs are in the relation defined by x squared y plus y squared equals 5. And then the follow-up question will be, is the relation a function? So, how do we decide which of these ordered pairs are in this relation? Plug them in. Because we know in an ordered pair where you're being given an x and a y, yes. So, and if we're plugging it into, what's our equation? X squared y plus y squared equals 5. So plug them in. So if we try it with the first one, x squared, so 2 squared times negative 5 plus negative 5 squared equals 5. And this is kind of where I say, okay, question mark. Does it equal 5? Do some math, right? 2 squared is 4 times negative 5 is negative 20. Negative 5 squared is 25. What do you know about negative 20 plus 25? Equals 5. So what do we know about this? It works, right? 5 does equal 5. And so we know that the ordered pair 2, negative 5, it is part of the relation. Okay? It does work. It made my equation true. Okay? Let's try another one. 1, 3. Same thing, right? The equation is x squared y plus y squared equals 5. We want to know if it works. So x squared, we're going to do 1 squared times 3 plus 3 squared. And the question is, does that equal 5? 1 squared is 1 times 3 is 3. 3 squared is 9. What is 3 plus 9? 12, I think. And what do we know about 12? It does not equal 5, does it? So, does the ordered pair 1, 3 work? It does not work. Okay. And we had what? One more pair? 2, 1. So plug it into x squared y plus y squared equals 5. 2 squared times 1 plus 1 squared equals 5. Let's see, 2 squared is 4. 4 times 1 is 4 plus 1 squared is 1. What do you know about 4 plus 1? It equals 5. And that was the ordered pair 2, 1. So 2, 1 does work, yes? So the first part, determine which of the ordered pairs are in the relation. We decided 2, -5 and 2, 1. And then the other part, is the relation a function? Okay? Our question here, is my relation a function? What?
No.
Why not?
Because it's the same x value.
Okay. If you just consider, we don't know what the graph of this looks like or anything like that, but if you just consider the two ordered pairs that are part of the function, we already decided that 2, -5 is part of the relation, and 2, 1 is part of the relation. So if it's a function, those are both part of the function. What's the issue here? Yeah, right here, folks, my x values repeat, doesn't it? Okay, I have an ordered pair that would be right 2, down 5, and an ordered pair that would be right 2, up 1. Those are on the same vertical line, yes? And since they're on the same vertical line, this is not a function. So it would not pass the vertical line test if you think in terms of a graph. But you also can go back to the domain value repeats. It pairs with two different y values, and that's not okay. Okay? So a little bit of review there about determining whether or not something is a function. Questions there? Okay. So we're going to take a little bit of time. I think I have this on the screen here. Yeah. To talk about relations defined parametrically. Okay? Relations defined parametrically, where both elements x and y of a relation are defined in terms of a parameter t. Now, I know that probably doesn't make any sense mentioning it, but here's what we're looking at. This right here, x equals t plus 1 and y equals t squared plus 2t. That is a parametric relation. Because while yes, it talks about x and y, there's a third variable in there. It's our parameter, and that is the t. Okay, so when we talk about parametric equations, they look a little different because x and y are defined. Now, we're going to do some different things with these. And I will tell you, remind me when I get to the end of this big problem, I think this is where I'll probably do it. You can also graph these on the calculator if you change the mode on your calculator. Okay, so we can talk about that a little bit as well. But, so, consider the set of all ordered pairs x, y defined by the equations x equals t plus 1 and y equals t squared plus 2t. First of all, part A. Find the points determined by t equals -3, -2, -1, 0, 1, 2, and 3. Okay. When we talk about find the points, what do you think about in terms of points? Huh? Okay, number line or x and y. Okay, so we're talking about finding the points here. We're trying to find x, y coordinates or ordered pairs. We have t's, yes? And what do we have besides t's? We have two equations. Okay, so when they're asking you to find the points, which will help us graph it and find the relationship in a little bit, we're going to plug them into those equations. Now, can I do it? I think I have room. I'm going to put my part A over here, and I'm going to kind of set up a table. Okay, in my first column, I'm going to end up with 4 columns here, but in my first column is going to be my t values. My t values, as provided, -3, -2, -1, 0, 1, 2, and 3. Those were provided, yes? No magic there. Now, the second column I'm going to use to find x. How do I find x? Yeah. X is defined to be t plus 1. So, What do we know? If t is negative 3, what do you know? Yeah. Negative 3 plus 1 is negative 2. Let's go ahead and do this entire x column. What about if t is negative 2? What's x? Negative 2 plus 1, which is negative 1. Do I need to write out the work each time? You can do the math, right? What about if t is negative 1? Negative 1 plus 1 is 0. If t is 0, 0 plus 1 is 1. If t is 1, 1 plus 1 is 2. If t is 2, 2 plus 1 is 3. And if t is 3, 3 plus 1 is 4. Okay, those are my x values. My final column, I'll put those together in like ordered pairs. Guess what? I did a t column, I did an x column. Guess what my next column is? Y. And how do we find y's? Y is t squared plus 2t. So I'll write out the work at the beginning. I won't do all of them, but that means I'm doing, so when t is negative 3, negative 3 squared plus 2 times negative 3. Negative 3 squared is 9. 2 times negative 3 is negative 6. 9 plus negative 6 is 3. We're repeating that process, yes? So if I plug in my next value, negative 2. Negative 2 squared plus 2 times negative 2. Negative 2 squared is 4. 2 times negative 2 is negative 4. 4 plus negative 4 is 0. If you want, you can keep writing the work out, or you can just plug them in. Or maybe you didn't write any work to begin with. So if I plug in, go back to your t value, negative 1. Negative 1 squared is 1. 2 times negative 1 is negative 2. 1 plus negative 2 is negative 1. Plug in 0. 0 squared is 0. 2 times 0 is 0. So we have 0. Plug in 1. 1 squared is 1. 2 times 1 is 2. 1 plus 2 is 3. Plug in 2. 2 squared is 4. 2 times 2 is 4. 4 plus 4 is 8. And plug in 3. 3 squared is 9. 2 times 3 is 6. 9 plus 6 is 15. Okay, I don't know if you saved any room or not. That's a horribly curvy line. Gosh. But my final column is just writing out my XY ordered pairs. Do we already have that information? Yeah. Okay, that's your final result. So when t is negative 3, what is my ordered pair? And that is negative 2 comma 3. When t is negative 2, my ordered pair is negative 1, 0. When t is negative 1, 0, negative 1. When t is 0, 1, 0. When t is 1, 2, 3. When t is 2, 3, 8. And when t is 3, 4, 15. Okay. Questions on that part? We're asked to find the points. It defines the information for us, so we did just that. That was part A. Not that you'd have to set a table up, but I feel like the table is the easiest part to do. Okay, let's try part B then, if you're ready. Part B asks us to find an algebraic relationship between x and y. And then it asks, is y a function of x? So that extra period should not be there. There we go. Get rid of it on my page. So, algebraic relationship between x and y. Again, we were given two equations, yes? What we're going to do is we're going to combine these two equations. Kind of through a substitution process. Basically, we want to get rid of t's. So we want to pick one of these equations and solve it for t. Which equation would you like to solve for t? The x equation? It's kind of a no-brainer here, isn't it? The one you can easily solve for t. So right here, x equals t plus 1. How do I solve that for t? Subtract 1, and then we're going to have t is equal to x minus 1, yes? Okay, so that was step 1. Step 1 is to solve an equation for t. Now, I said it was kind of like a substitution thing, right? You have one equation solved for t. Take that equation you have solved for t, and what are you thinking? Plug it into your other equation. So my other equation is y equals t squared plus 2t, right? Okay, guys. Every place I see a t, I'm replacing with x minus 1. So we're going to have y equals t squared. I'm going to write as x minus 1 quantity squared plus 2t. So 2 times x minus 1. And if you want a note of what we did, we plugged t into the other equation. Now, as you think about this, I do have us going farther here because we do also have to answer, is this a function? Okay, so we are going to have to ask that here in a moment, but in that purpose, I do have us going a little bit farther. How do we deal with x minus 1 quantity squared? Distribute. Think FOIL if you want, right? So x minus 1 times x minus 1. If we FOIL that out, x times x is x squared. Outside, x times minus 1 is minus 1x. Insides, negative 1 times x is negative 1x. And negative 1x and another negative 1x is going to be a negative 2x. Negative 1 times negative 1 is plus 1. And don't forget, you also need to distribute that too. And so I have plus 2x minus 2. Is there cleanup that can be done? Just a little bit. Let's see. I see an x squared. What else? Minus 2x plus 2x is canceling out. And I'm left with 1 minus 2, which is minus 1. So right there, it asks us to find the algebraic relationship. That is y equals x squared minus 1. So we went from having two equations that are in terms of this parameter t that I don't really know a whole lot about, to we now have one algebraic relationship between x and y.
So when we do homework, will it be like different equations for x and y?
In terms of like other problems like this, is that what you're
Yeah.
asking?
So
Yeah.
like x would be like t squared plus minus t.
Yeah, you'll have different
Okay.
things. Yeah.
I mean, duh.
I mean, it will be, and some of them will be similar to this where, you know, pretty basic. And then there'll be some that, I'm trying to think of this is where there's a couple special cases that come up that we'll talk about too. So, okay, to finish up B, is this a function?
Yeah.
So I'm going to follow that up with why.
Because there's an x values.
Okay, the x values aren't repeating. Okay,
Passes the vertical line test.
okay. What passes the vertical line test?
X squared minus
Okay. Both valid thoughts, right? If I start thinking about does x repeat, every time I plug an x value in, can I get more than one y value to go with it? No, I plug an x value of 0, there's only going to be one answer pop out of that equation. I plug in 5, there's only one answer that pops out of that. I'm not getting it paired with two different pieces. And then in terms of passes the vertical line test, what do you know about y equals x squared minus 1? It's a parabola, yes? It's that parabola moved down 1. So, is it a function? Yes. It is a function. Okay. Now, part C. Did I leave enough room? Part C asks us to graph the relation on the coordinate plane. Now, we kind of already just talked about the graph, but when we talk, what part C is wanting us to do is graph the relation on the coordinate plane based on part A. Okay, so based on this. Now, with that in mind, I'm going to be smart about how I set this up. And I'll be honest, I probably didn't graph the 15 on my paper. But so I have my y-axis kind of centered in my remaining space. My x-axis, I'm going to be smart, I put it down kind of low. Because we need to go much below the x-axis. No, we only have one negative value, and it's just a negative 1. So, let's see. Need to be able to go as far as 2 left. Officially, technically, 4 right, based on the order of pairs we came up with. Supposed to be able to go up 15. I'll be happy with up 8. Huh? If I let myself keep going up, I can get up to 15. Yeah. Don't stress about it, though. Okay, so you are graphing the ordered pairs from part A. That's what we're graphing here, okay, guys? So, negative 2, 3, we're going to go left 2, up 3. Negative 1, 0. Left 1, up 0. 0, negative 1. It's down 1. 1, 0. What did I do? Goodness. Okay. Did I say the right thing and just draw the wrong thing? That's my guess. Left 2, up 3. Left 1, up or down 0. 0, negative 1. Left, right, 0, down 1. 1, 0. Right 1, up 0. Right 2, up 3. Right 3, up 8. And if you made it happen, right 4, up 15. What do you think? Is it looking like what we expected it to look like? I'm going with, I did not draw my graph very well. Ooh, this is rough. Now, officially my point's in lower on one side than the other. But does that really mean my graph ends lower on one side than the other? No, it's just the way the points are. And in fact, I feel like I probably should extend that up. Probably should have extended even more. Okay. Now, I forgot to look. Okay. You would have two options to graph this on the calculator. And I forget what homework expects. So I will mention that tomorrow, especially with having 3 people gone this morning. I will mention that tomorrow if I need to graph those on the calculator for you. But it's just when you're in mode, when you go to your mode setting on your calculator, one of the options is to change out of, what is it, function mode, I think, to parametric mode. And then when you go into your y equals screen, your y equals screen no longer just says y equals, it's like in pairs. X equals y equals. So, yeah. Yeah, we'll graph this. We'll come back and graph this one on the calculator tomorrow so I can show it to everybody. Okay. Bottom of the page. A little information about inverses. We talked about inverses back in Algebra 2. What you remember is a whole nother story, right? But we talked about them, I promise. Some of this will sound familiar. So, inverses. If an ordered pair AB is part of a relation, then the ordered pair BA is in the inverse relation. So remember, in an inverse, your x value and your y value can flip-flop. Okay? And so that's where it talks about AB in an inverse is BA. So those can flip-flop. If a function has an inverse, then it will pass the horizontal line test. So vertical line test, what do we do? Draw a vertical line and it's only allowed to pass through the graph once to pass. Horizontal line test, draw a horizontal line and it's only allowed to pass through the graph once. Okay, if it only passes through the graph once, then what that's saying is that the function has an inverse. Okay, if it passes the horizontal line test, it's saying that an inverse does exist. Okay, easy to use. Functions that have inverses are called one-to-one. So if it's a function, it's going to pass the vertical line test, right? If it has an inverse, it's going to pass the horizontal line test. And so a function that is one-to-one is going to pass both the horizontal and vertical line test. So I'm going to write a note there. Passes both horizontal and vertical line test. Okay. I know we talked about this last year in Algebra 2. The inverse of a function f of x is written as f negative 1 of x. I read it as f inverse of x. But that's your inverse notation. I remember doing that in Algebra 2 with you guys. And we're going to do this on the back side. Maybe today, maybe tomorrow. To find an inverse function, take your x and your y and you switch them. And then once you switch them, you solve for y. Okay? And we will practice that in example 4. But we've got to get through example 3 first. So, we can get through an example 3 in 5 minutes. I'll probably just leave us example 4 to start with tomorrow. Okay. So, as you flip to the back side of your notes,
Yes.
which of the following graphs are A, relations that are functions, and B, relations that have inverses? So A is asking, are they relations that are functions? How am I going to assess that? Okay, so on part A, you're going to be checking to see, does it pass the vertical line test? Part B, ask us, are they relations that have inverses? How am I going to assess if it has an inverse? If it passes the horizontal line test. Okay, you ready to give this a whirl? On A, or I guess, no, example 1. It's not labeled A, is it? Example 1. We have a question A and a question B on each of these. So let's start with, on example 1, is this a function? Yes?
Yes.
It's a function because it, agreed? I can draw a vertical line here, I can draw a vertical line here. Any place I draw a vertical line, it's only going to pass through once, yes? So it is, yes, it is a function. B. So we also have a question B to answer on every problem here. Does this have an inverse? How do I assess whether or not it has an inverse? Does this pass the horizontal line test?
Yes.
Any place I draw a line, it'll just pass through the graph once? Correct? Okay. And so, yes. So this one, yes, it's a function. Yes, it has an inverse. While we're here, what's the special name for this one then? It is a hyperbola, but not what I was looking for. 1-to-1. If it is a function and has an inverse, it is what we call 1-to-1. Okay? B. Is it a function?
No.
There we go. Good example right there. Not a function. It just failed the vertical line test. Yes? We can still ask the question though. Does it have an inverse?
Yes.
Okay. What's happening in between each of these sections of graph? Are you realizing that these are horizontal asymptotes? Okay, there's horizontal asymptotes running through, which means, does it overlap at all? No, it doesn't overlap. So yes, it has an inverse. What about example 3? Definitely not a function, is it? And does not have an inverse. So no and no. And example 4. Is it a function? Yeah. Again, realize that there are vertical asymptotes happening here. That's okay. Yes, it's a function. Does it have an inverse? No. Whether you draw up top or down low, it fails the vertical line test. Okay. Sorry. I wanted to squeeze that last set in. We'll talk about example 4 and 5 tomorrow, or 5 and 6, I guess. And that will make homework due on Wednesday.
Oh, I have